and you launch a particle. You launch a particle with some initial velocity. Suppose initial velocity is u, and then after launching, this particle is free to move or travel under the influence of the gravity of the Earth, like this. Then this type of motion is called as projectile motion. Then this type of motion is called as projectile motion. So this is a particle. You can call it as projectile. So what we call it? We call it as projectile. So I'm considering this as y-axis here. This is y-axis. And this is x-axis. X-axis. And this particle which is projected, this is called as projectile. What do you call it? You call it projectile. So when you launch this projectile at an angle theta with some initial velocity, and then this particle is free to travel under the influence of gravity only, no other force is acting, then this type of motion it is going to be called as projectile motion. See, you call it as projectile motion. So here what is important in this case, in case of projectile motion, only one type of force is there, that is G. Gravitational force is acting. So a gravitational acceleration in the downward direction, that is always going to act. So throughout this motion, only one force, that is in the vertically downward direction, that is gravitational force, that is acting. In the horizontal direction, there is no force. So first important thing here is that only gravitational force is present. Only gravitational force is present here. Gravitational force is present. Force is present. In which direction this force is acting? This force is acting in the vertically downward direction. So there is an acceleration in the downward direction, g, or you can write it as minus g because it is acting in the downward direction. So there is always an acceleration in the downward direction. So this vertical motion in the y direction, that will be accelerated motion. Second, in the horizontal direction, there is no force. So there is no force acting. There is no force acting in the horizontal direction. Acting in the horizontal direction.
सर
In the horizontal direction. Yes, beta?
वो एक्स डायरेक्शन में क्या मतलब इनिशियली जिस फोर्स से फेंका गया था उसका एक्स कंपोनेंट भी नहीं होगा क्या?
No, velocity, it will have a velocity component. So whatever velocity component will be there, that will be here. So if you are launching the particle with initial velocity u, then there will be a horizontal velocity component that will be u cos theta. And there will be a vertical component of this that will be u sin theta. So in case of projectile motion, because there is no force in the horizontal direction, there is no force in horizontal direction. So what is going to happen? Here, acceleration will be 0. So AX, acceleration in the X direction, that will be 0. What will be the result of this? That this velocity in the horizontal direction, velocity component in the horizontal direction, that will remain same throughout the motion. So velocity component, velocity component, just 1 second, component in the horizontal direction, in the horizontal direction will remain constant, will remain constant, constant. So this Vx, that will always be equal to Ux, and this will be u cos theta. So horizontal component, it will always be u cos theta. Yes, beta, please.
Sir, I can't understand second point.
Okay. So basically, if some object is moving, with an initial velocity u and no force is acting on it, there is no force acting on this particle, then what is going to happen? F will be equal to ma, ठीक है, ma, that is 0, mass of this particle is m, so acceleration is 0. When acceleration is 0, suppose this is 1D motion, for example, just for your understanding, this Vx, that will be equal to ux plus at, because a is constant here, acceleration is 0. So this will be x component, acceleration in the x component, and that will be v equal to u plus at. So ax is 0. So this ax is going to be 0. So throughout the motion, this Vx, that will be equal to ux. If no force is acting in the horizontal direction, acceleration will be 0. When acceleration is 0, particle is going to move with the same velocity, whatever velocity it is going to have. ठीक है ना? That is also called as inertia. ठीक है? This is also called as inertia. So due to the property of inertia, it will continue to move in the horizontal direction with the same component. Now, come back to this. So basically here in projectile motion, before understanding this projectile motion, I make it very clear that only one force is acting in the downward direction and particle is moving or traveling under the influence of gravitational force only. In horizontal direction, there is no force acting. So that's why I am saying whatever is the initial x component of the velocity, throughout the motion, x component of velocity will remain same. X component of velocity will remain same. Now, come back to this. Now, this projectile motion, what is most important thing? This is a two-dimensional motion. What type of motion is this? This is 2D motion. 2D motion. It takes place in a plane. Okay? It takes place in a plane. It takes place in a plane. In a plane. So that's why I have chosen XY plane. So I'm saying this projectile motion is taking place in the XY plane. Horizontal distances, they are represented by X, and vertical distances, they are represented by the Y cap. ठीक है ना? Y cap direction is the vertical direction. ठीक है? So this is a two-dimensional motion. Now, this projectile motion, this projectile motion can be considered as this projectile motion, it can be considered as the superposition of two one-dimensional motion. ठीक है? It can be considered as the superposition of two 1D motion, of two 1D motions. 1D motion. ठीक है? One along the x direction, and second along the y direction, and second along the y direction. Y direction. What is the meaning of this? This. So here, this is our projectile motion. I'm again drawing this. This is x. This is y here. Particle is launched like this with some initial velocity u. So this is u, and it is launched at an angle theta. Now, x component of this, I will write ux initial X component initial velocity in the X direction, that is Ux. It is how much? This is U cos theta. What is theta? Theta is called as projection angle. Theta is called as projection angle. And this vertical component, that is Uy. You call it as Uy. And this is called as U sine theta. U sine theta. So this is Ux and Uy. Okay? Now, how can you consider it as a superposition of two different 1D motion? First motion, ठीक है ना? First motion I can consider like this. So this is a particle, suppose it is moving, it is launched or moving with u cos theta. This is ux. So this point is O, from where it is starting its journey. So this point is O, and I call this as A, where it is again hitting the ground. So from O to A, it will travel horizontal distance. See, so this is the motion along the x direction. One motion is this. Throughout the motion, it is shifting in the x cap direction. Continuously when particle is here. So it has traveled this much of x distance. So basically, it is now here. It has traveled this x distance when particle is here. It has traveled this x distance. So continuously, x coordinate of this particle, it is continuously increasing. And when it will hit the ground, ठीक है ना, at the point A, up to this point, this x coordinate is going to increase. ठीक है? So one motion will be this. This is 1D motion. What will be the equation for this? What will be the equation for this? How much distance x it will travel in time t? It will travel, suppose, x distance in time t. So what will be x? Velocity u cos theta multiplied by t. So what I am saying here, suppose this particle traveled x distance here. This traveled x distance in time t. Here, suppose time is t. Then what will be x? X is u cos theta into t. Why I'm writing like this? Because u cos theta is constant throughout. Anywhere you can consider, if you are considering this particle, this will be Vx, this will be u cos theta. Even at this point, highest point, horizontal component of velocity, that will be u cos theta. If you consider this point, ठीक है ना, it will have this velocity. So there will be a vertical component, there will be a horizontal component. Horizontal component will be u cos theta. Even at this point, A, basically here, its particle velocity will be like this. So a component it will have in this direction, a component will be here. So what will be this component? This will be u cos theta. So throughout the motion, from the starting point to the hitting point here, horizontal component, that will be u cos theta. So x will be equal to u cos theta into t. ठीक है ना? This is 1D motion. Now second is, throughout its motion, it is moving up. So try to understand here, this is y distance. This y distance is increasing. So in the first half of its journey, y is increasing. So if you look at the position of this particle, its y coordinate is increasing from here to here. And then y coordinate of it is decreasing and it will become 0 here. So how can you write this? Second, how can consider, suppose I launch this particle from the ground in the vertically upward direction with a velocity uy is equal to u sine theta. So what will happen? It will go, if you launch the particle in vertically upward direction, then what is going to happen? Basically, its velocity is going to decrease. It will, at the highest point, it will have a 0 velocity. So here Vy, it will be 0 at the highest point, and then it will fall down. It will fall in the downward direction and it will reach the ground in this way. So this type of journey you can consider in the y direction. So this type here at the highest point, if you look at this highest point, this is Vx, and here at the highest point, this will be Vy, and Vy will be 0. So remember this aspect that highest point Vy will be 0. So basically this this projectile motion this projectile motion can be considered as the superposition of these two different 1D motion, one along the x direction, second is along the y directions. Here, this motion, vertical motion, this is accelerated motion. G is acting in the downward direction here, and here acceleration is 0 here. Here acceleration is 0. You can consider in this way. Now, what will be the equation for this? Can you tell me what will be y? What will be this position y? Okay. Suppose you consider this point. Okay. I'm considering this point here, and I'm saying its coordinate of this point. This is y, this is x. So I'm saying at any time t, particle is here at x and y. They are the coordinates. What is the time here? I'm saying time is t. At time t, position of this projectile is x comma y, and time is t. Okay. So what will be y? X will be how much? X will be u cos theta into t. This will be the x coordinate. What will be the y coordinate here? Y coordinate, you can consider this y equal to uy into t. It is moving in the upward direction, so minus 1 by 2 gt square. This will be, so this will be y equal to uy is u sine theta into t. Okay, this will be u sine theta into t minus, this will be g, and time t, this will be gt square, or I can write simply half of gt square. So I write it more accurately. This will be u sine theta into t minus 1 by 2 gt square. So this will be the y coordinate, beta. So
Sir,
for just 1 second, beta. The position of the particle at any time t throughout its motion can be governed by this equation. If you know the time t, then you can tell me what are the coordinates of the projectile at that time with the help of this equation. With the help of this equation. Yes, beta, please.
sir, I can't understand y is equal to uyt minus half gt square.
This is a equation. ठीक है ना? This is a equation for 1D motion when acceleration is constant. So when acceleration is constant, or uniformly accelerated motion, uniformly accelerated motion, rated motion. You have three equations with the help of which you can find out the position, time. You have correlations between the velocity, position, x, and time. They are v equal to u plus 80. ठीक है. Next is s equal to ut plus 1 by 2 at square. V square is equal to u square plus 2as. So here I'm using this equation. This time motion is, you are launching the particle in the upward direction. So initial velocity is given uy, because motion is in y direction. In place of u, I am writing uy, and this is u sine theta. This is u sine theta. ठीक है? Acceleration during its journey, throughout the acceleration, it is in downward direction. So I'm taking it as minus g here. So if I place here, so what will be s? s, or you can say y, or you can say y, distance traveled by this particle, ठीक है ना? At any time t, this will be y will be uy into t, because velocity in this direction, acceleration in downward direction, so this is a de-accelerated motion, minus 1 by 2 gt square. So in place of a, I am writing minus g here. So this equation I am using there. Is it clear now? Why I am
Yes, sir.
using? So I am using this equation. ठीक है? So this is the equation that I am using. Just where is this? This one. So now I am having two equations. So x coordinate is governed by this equation. Y coordinate is governed by this equation. Now substitute this t from here. From here, I can find out t. Why I am finding out t? This is x upon u cos theta. Why? I want to find out because I want to find out the trajectory of this projectile motion. I want to find out the trajectory of the projectile motion. And whenever you are finding trajectory, you have to eliminate t. Whenever you want to find out the trajectory, you have to find out the correlation between x and y. By eliminating t here, so by eliminating t in these two equations, I am going to establish a correlation between x and y. How? Y changing with x. As you are changing x coordinate, how y is going to change. So that equation is known as the trajectory, equation of the trajectory. Okay, that is called as the equation of the trajectory. So first is equation of the trajectory. Equation of the trajectory. So what I find out? I find out that time t is x upon u cos theta. U cos theta. And what is y? Y is u sin theta. U sin theta into t minus 1 by 2 gt square. Substitute this t here. So if you substitute t here, then what is this? Will have u sin theta. In place of t, this will be x upon u cos theta. U cos theta minus 1 by 2 g, and this will be x square, or you can write x upon u cos theta and square of this. So here this u is going to cancel out, and equation of trajectory will be x, this will be tan theta. This will be x tan theta minus 1 by 2, or you can write here gx square. This is gx square upon 2 times u square cos square theta. This will be. Now, this is the equation of the trajectory. First thing you have to remember. This. Second, you want to find out time of flight. For how much time it is undergoing motion? It is undergoing projectile motion. The time during which it is undergoing projectile motion, that is called as time of flight. So next is you want to find out time of flight. Is it clear? Trajectory equation.
Yes, sir.
Yes, sir.
Next is time of flight. I'm saying, suppose this particle is hitting back here. I'm saying particle is hitting back at this point at time t. At time t, particle is hitting back at this point A. I'm saying this point is A. So for capital T time, it is traveling. For capital T time, it is traveling. Can you tell me at point O, what is the y coordinate here? You are going to tell me the y coordinate here at point O. That is 0. Y is 0. And what is the y coordinate here at this point?
Zero.
Again y equal to 0. So there are 2 points only in the projectile motion where y is 0. So y 0, if I'm substituting y equal to 0 here, try to understand. I will get two values of t, time. One will be corresponding to this point O from where we are launching this projectile. Second time t will be corresponding to the time when it is hitting the ground, when projectile is hitting the ground. So what I'm saying here, simply just place this y0 here. So what you are going to do, you are going to place y equal to 0. Y equal to 0. Now your equation will be 0. This equation, look at this, u sine theta into t. This will be u sine theta. In any way you can do this calculation. In many ways you can do, but in general student don't do calculation in this way. That's why I'm telling you this method. Minus 1 by 2 gt square. Gt square, take t common. So this will be 0. If I take t common, this will be u sine theta minus 1 by 2 gt. So you are going to get two different values of t. You can say t1, that is 0. ठीक है ना? First will be 0. So this is representing projectile point. ठीक है ना? This is starting point. This is starting time. Starting time of projectile motion. And second will give you capital T, and it will be 2u sine theta. 2u sine theta upon g. So this is called as time of flight. What do you call? You call it as time of flight. ठीक है ना? You call it as time of flight. Is it okay with everyone? Now, basically here, from your class 10 or 9, when you have studied this 1D motion in vertical direction, you know that whatever time this is going to take from here to here, ठीक है ना? From lowest point to the highest point, this point time from here to here, ठीक है, that will be u sine theta upon g. Same time it is going to take in the reverse, in the downward motion. So that time will also be u sine theta upon g. So you call it as T2, second half, and you call it as first half. So in the first half and second half journey, equal time is taken by the particle. So for this projectile motion from here to here, ठीक है ना, here at what time particle will be here? At the highest point, particle will be at t equal to, I call it as T1 u sine theta upon g. And when particle will be here, that will be capital T, that will be 2 times of this. This will be 2u sine theta upon g. This will be the capital T. ठीक है, half of the journey will be in u sine theta upon g, rest half of the journey will be again in u sine theta upon g. So total time here is 2u sine theta upon g. Now second, what is u sine theta? Can anyone remember? That is actually initial velocity in the y direction, so you can also write like this. This will be. Next will be, I want to find out the range. What I want to do, I want to find out this range. Range means how much horizontal distance, total horizontal distance particle has traveled in capital T time. During its time of flight, how much distance is traveled by the particle? This distance from here to here, this is called as r. and r will be equal to, it is called as range of the projectile motion. This is called as the range of the projectile motion. How can you find out? Very easy. How much maximum distance this r, this x will be r, u cos theta is constant. How much time is taken by the particle to cover this complete range? That is 2u sine theta upon g. So if I place 2u sine theta upon g here, that will give me the range. Simple. So x will be u cos theta into capital T. That will be the range. So what will be the range here? Range of the projectile motion. Next is range of the projectile motion. Range of the projectile motion. So maximum horizontal distance traveled by the projectile motion is called as range. So what is range? Range is maximum horizontal distance, or total, or you not you don't write maximum, you can write ठीक है horizontal distance, horizontal distance traveled by particle, travel by the particle, by the particle in time t. I'm not writing exact definition. In time t, this. So what will be range? Range will be simply horizontal component ux into capital T. So ux is u cos theta, and that time is 2u sin theta upon g. So u into u is square. So what will be the range? Range is u square, and this is 2 times sin theta cos theta. 2 times sin theta cos theta will be sin 2 theta. So this will be u square sin 2 theta upon g. So this is the formula of the range. U square sin 2 theta upon this. I can also write this formula in another way. Range is here. I'm writing 2 here. 2 is here. This is u cos theta. So I'm writing u cos theta here. Second here, it is u sin theta. U sin theta divided by, this will be g. This will be g. So what will be r? R can also be written as 2 times, what is u cos theta? Ux. What is u sin theta? This is uy upon g. You can also write the range of the projectile motion in this way. So r is equal to 2 times ux uy upon g. Ux uy upon g. Is it okay? Second, ठीक है, this is the range when you are launching the particle at theta. Now can you tell me what will be the range if particle is launched at 90 minus theta angle? So here projection angle is theta. Then range is this one. Range is this one when you are launching the projectile at an angle theta with the horizontal. Now suppose if projectile is launched, if projectile is launched at an angle, at an angle 90 minus theta with the horizontal, with the horizontal, with the horizontal. Then what will be the range? I am writing it as R1. Then range will be R1. What will be range? That will be U square. And this will be sine 2 times 90 minus theta. And that will be G. So this will be U square. This is 180 minus 2 theta. So this will be U square sine 2 theta upon G. So even in this case, what you are finding, range remains same. Range remains same. Range of the projectile motion will be same. For theta, for the projection angles, theta and 90 minus theta, if initial velocity is same. If initial velocity is same. So you can write range of the projectile motion of the projectile motion remains same same if projection angles are projection angles are theta and 90 minus theta. But what is the condition here? U will remain same. U should be same. U should be same. This will be. So you have to remember this. At theta and 90 minus theta, if you are launching the particle, and if in both cases, ठीक है, initial velocity is same, then range will be same. Then range will be same. Is it okay?
Yes, sir.
Yes, sir.
Now, next is equation of trajectory.
Sir, there is one slide after this, which is a previous slide, which you might have missed.
Yes, but actually I have explained this one, this is extra. So that's why I'm keeping it in the last.
Okay, sir.
So equation of trajectory again. Equation of trajectory again. You will find out 4 or 5 questions from the projectile motion they have asked in the exam in PYQs. You can find out. I will discuss those questions after completing this. After the complete discussion of kinematics, I will discuss all the questions related to these topics. So now, what was the equation of trajectory? What we have find out, tan theta into x minus gx square. कितना था बेटा यहाँ पे? This was 2 times u square cos square theta beta. This was. This is. Now if you take this x tan theta common, ठीक है? Try to understand if you take this x tan theta common out, what you are going to have here, this will be 1 minus 1x is gone. So this will be gx only. And here you are going to have 2u square cos square theta, and this will be tan theta. So tan theta is sin theta upon cos theta. So 1 cos theta will cancel out. 2 sin theta cos theta will be sin 2 theta. So if you simplify it, you will find out this is x tan theta. 1 minus, this will be g. I'm just keeping it like this. This is g here divided by this will be u square. U square. This is 2 here. 1 sin theta from here. 1 cos theta will be here. So u square sin 2 theta. Bring this g in the denominator here. So I'm removing this g from here. So this will be x and g will be here. And this is the formula of the range. So you can also remember this equation as equation of trajectory, x tan theta. Many times it is very helpful. X upon range capital R. This is another form of equation of trajectory of projectile motion. This one. Is it okay? ठीक है बेटा. Next.
Yes.
What will be the maximum height? Next is maximum height. So if you look here, this maximum height, I want to find out this. I want to find out this height. H max. I call it as capital H. I want to find out. So basically, look here. Consider this part. So this will be the maximum height. And you know that to find out capital H, you will use the fact that at the highest point, this Vy will be 0. At the highest point, Vy will be 0. And distance traveled by this in the upward direction, suppose that is H. You are saying this is the maximum height this projectile is going to achieve during this projectile motion. So this is maximum height H. Maximum height. Maximum height will be Vy square. I'm using third equation is equal to Uy square minus 2g. It is upward motion and this will be H. Vy 0 at the highest point. This is Uy is U sine theta. So it will be square of this and minus 2gh. This will be. So what will be the maximum height H? H will be equal to U square sine square theta upon 2g.
Sir,
Yes, beta.
I can't understand first equation. Uy square is equal to uy square minus 2gh.
This is a third equation. No, I told you here. There are three equations. Okay, for constant acceleration, because acceleration is constant. So you can use this equation. This is Uy square is U square. So here, look here, G is acceleration is how much? That is minus G. In the upward direction, so I'm representing this U by Uy. So I'm writing Uy square in place of U. What will be the velocity in the upward direction? That will be after time t, that will be Vy square. Why I am writing? Because it is moving in the y direction. A is minus G, so I'm writing minus 2G. A is minus G here, and this is H. Okay? You can write it as H. And at the highest point when it will be here, this Vy, that is going to be 0. And height, I am saying this is H. So Vy, this is 0, 0. And this Vy is U sine theta. Make the square of this. And minus 2, G highest point is at a height H, capital H. So from here, I'm getting that. From here, I'm getting the value of H. Is it clear now? So
Yes,
I'm
sir.
using this equation. So this will be. Okay? So I have find out most of the parameters here. I have find out most of the parameters here. Is it okay? So can you tell me when this range will be maximum? Now, some important facts.
So
Number
previous
one.
slide.
Okay. Beta.
Done, sir.
Okay. So first, First point, maximum range. What will be the maximum range? When we are going to get maximum range. So what is range here? Range is u square sine 2 theta upon g. ठीक है, u, I am not going to change u and I want maximum range. What I want to hear, maximum range without changing u. U should not change, but means magnitude of the velocity should not change, but range should be maximum. So for maximum range, for maximum range, this sine 2 theta, it should be equal to maximum. It should be maximum. What is the maximum value of sine?
1 plus.
That is plus 1 beta. Correct? That is plus 1. ठीक है, साइन varies from -1 to +1, so maximum value of sine is +1. Only when this is +1, maximum value r will be max. So here, from here, you know that this will be pi by 2. So what will be theta? Theta will be pi by 4 or 45 degree beta. So when you are launching the particle, at an angle 45 degree, with the horizontal, you will get the maximum range. So maximum range, R max, that will be equal to, place here 1, that will be u square upon g. ठीक है, and it is achieved when it is achieved when theta projection angle is 45 degree. ठीक है, this will be, that is 45 degree. So this will be the maximum range. This is the maximum range. It is okay.
Yes, sir.
What should be there for the maximum height? Maximum height, I can say second point, maximum height. Maximum height. So h is how much? U square sine square theta upon g upon 2g. यही है बेटा, ठीक है, u square sine square theta upon 2g. Can you tell me, without changing u, how can it be maximum when sine square theta? So h will be maximum. H will be maximum simply when sine square theta is 1. So it may be plus minus 1, but we are not going to launch the particle in the downward direction. We are launching in the upward. So here means sine theta is plus 1. So this theta should be 90 degree. Means you are launching the particle. It means H will be maximum when particle is launched in vertically upward direction. So what you are going to do here, when theta is 90, you are launching like this. So this angle, launching angle, projection angle is 90 degree. So this H will be maximum when particle is launched in vertically upward direction, upward direction. This will be. ठीक है. So this is another point. This is another point. ठीक है. Next, at the highest point, third, I want to find out third. You have to find out the ratio of find the ratio of kinetic energy to potential energy at the highest point.
Sir, previous slide.
Just 1 second, beta. At the highest point. I'm just showing beta highest point. You can.
Sir,
Sir, here H is equal to U square by 2G, right? At the end.
U square upon highest point. Highest is this H max. That will be U square upon 2G. And it is very clear. It will be U. So if you are launching the particle with this, so what will be the highest H here? What will be H here if you look at V square V0 equal to U square, highest point V0 here. So V square is 0 equal to U square minus 2G H. And you know that H equal to U square upon 2G. So you're getting the same number here. So H max is only when you are launching the particle in the vertical direction, vertically upward direction.
सर,
Yes, beta, please.
एक डाउट है. जैसे
बोलिए.
वर्टिकल डायरेक्शन में इफ थीटा इज 90 देन वी आर गेटिंग एच मैक्स, राइट? तो इफ वी थ्रो द बॉल विथ थीटा इज इक्वल्स टू 0, उस केस में हॉरिजॉन्टली लाइक मैक्सिमम डिस्टेंस नहीं मिलना चाहिए था? मतलब ड्यू टू दैट फ्रिक्शन वो कम हो जाता है, ऐसी कुछ है क्या?
No, we will discuss that question, beta. ठीक है ना? Your question is quite good. You want to find out what is the question? I will discuss this question.
When we are throwing.
Just I will discuss after 1 or 2 class.
Okay.
So question is this. Try to you can solve. You can try to solve. I'm launching the particle like this. This exact question is this. Suppose this is horizontal direction and you are launching this. Okay, you are launching this particle, suppose like this. So this particle will undergo this type of motion. This type of trajectory it is going to follow. You want this is R, and you want that this R should be maximum. You have to find out this angle theta so that this R will be maximum. So first you find out for journal values, you are going to find out for journal theta. Try to understand, choose any theta, find out this range R. Then apply this for maximum range. For maximum range, ठीक है, this dr by d theta, that should be 0. So from here you find out theta, substitute back in the formula of range, and you will find out the angle at which you are going to get the maximum range. ठीक है, and that will not be horizontal. That is not going to be horizontal. I will come to this point, but in this way you can solve this question. This was your question, if I am not wrong. Now, इसे थोड़ा change करो बेटा. Make it that will give you a better expression. So find the ratio of potential energy to kinetic energy. That question is quite good and important. So find this ratio at the highest point. ठीक है? You are going to tell me. Now, remember this total mechanical energy. Total mechanical energy. Energy. Kinetic energy plus potential energy will remain constant. Will remain constant. Remain constant at every point throughout the motion. Why? Because only one force is acting, that is gravitational force, and gravitational force is conservative. ठीक ना? Will remain constant. Why? Because gravitational force under which this motion is taking place is conservative in nature. Force is conservative. I will explain you the meaning of conservative force in work energy chapter. Conservative force. ठीक है? That's why. At the launching point, at launching point, at launching point, what will be the energy, total energy? That will be E. E will be 1 by 2 with what velocity you are launching with U, and potential energy is 0 because height is 0. At the launching point, you are launching the particle from the ground, so height is 0, potential energy is 0, and this is total energy. ठीक है? At highest point, what will be the kinetic energy? 1 by 2 m. What will be the velocity at the highest point?
0.
Try to understand this type of projectile motion. At this point, only horizontal component will be there. ठीक है? ux, or you can say it as vx. At this point, this will be vx, and that will be u cos theta. This vy is 0 here. So kinetic energy will be due to this component. So this will be m u cos theta square. So that will be 1 by 2 mu square cos square theta. This is kinetic energy at the highest point. What will be the potential energy? That potential energy will be total energy minus kinetic energy. Total energy is this. This is the total energy. 1 by 2 mu square minus kinetic energy is 1 by 2 mu square cos square theta. So this will be 1 minus cos square theta. So potential energy will be 1 by 2 mu square, and this will be sin square theta. So what will be the ratio of potential energy U and kinetic energy? U is 1 by 2 mu square, 1 by 2 mu square sin square theta divided by 1 by 2 mu square cos square theta. So U by K, that is equal to tan square theta. So this will be the ratio of potential energy to the kinetic energy at the highest point. Always remember. And if you are launching the particle with theta, if theta is equal to 45 degree, then this will be tan 45. So that will be 1. So in that case, at the highest point, potential energy will be equal to the kinetic energy. So if you are launching the projectile at an angle 45 degree with the horizontal, then at the highest point, potential energy and kinetic energy, they will be equal, beta. Potential energy and kinetic energy will be equal. Is it clear? Hello?
Yes,
Yes,
sir.
sir.
Please quickly note down it. ठीक है? Note it down very quickly. करिए बेटा जल्दी। Next, another question may be, suppose this is a tower whose height is h, ठीक है, whose height is h. So, and projectile is launched from this point. You are launching the projectile from this point. ठीक है, suppose you launch in horizontal direction. Try to understand first. Suppose this is u, this is u. So what will happen if you are launching this? Then after launching, this will be this type of trajectory it is going to have. This will be the trajectory. If this height is h, tower height is h, and this will be here. Try to understand. This point is I'm considering at 0, 0. So what I'm considering it, you can consider this point as origin 0, 0. Then this point will be 0 and minus h. This will be minus h. ठीक है, and here this will be r. So this will be, ये कितना हो जाएगा बेटा? This will be r, range, you call it as range from here to here, range, and this will be minus h. Minus h. This will be. Is it okay? So in this way you can consider it. So this is r and h. You want to write, suppose your particle is here. ठीक है? Your particle is here. And you want to write its velocity components as well as x and y components. So at time t, my particle is here. So what is going to happen? It will have some velocity like this. This will be v. I resolve this into two components. This will be vx and this will be vy. Remember this. At any point it will be. Because only this gravitational force is acting. So gravitational acceleration is there in the downward direction. ठीक है? This will be. So what will be vy? Oh, sorry, vx first. What will be vx? Vx will remain constant. Vx will be equal to u. Because you have launched the particle horizontally. This will be. So this will be. Now here, this u is actually ux. Ux. So ux is how much, that is u. And what will be here? Uy. Uy0. There is no component of velocity in the vertically downward direction or upward direction. So Uy0. Uy0. So what will be Vy? Vy will be equal to, at this point, this will be Uy, Uy, and this will be, कितना होगा बेटा? This will be gt or minus gt, you can write. Minus gt. Minus gt. Now Uy0. Uy0. So this will be minus gt. So this will be Vy. Vy will be equal to minus gt. And what will be Vx? That will be u. In this way, sorry, in this way you are going to get. In this way you are going to get in case of horizontal, if you are launching the particle horizontally. What will be the coordinates here? Suppose coordinate of this is x and y. Suppose coordinate of this is x comma y in time t. So x you can write, ठीक है, कितना होगा बेटा x? X will be this ux, so that is u into t. And if you take the dx by dt, you are going to get this u. What will be y? ठीक है, what will be the coordinate y? ठीक है, y कितना होगा? y will be this will be uyt minus 1 by 2 gt square. uy is 0, so y coordinate that will be minus 1 by 2 gt square. If you differentiate this y, you are going to get minus gt. So they are x and y coordinate in this case. In this case. ठीक है ना? This will be.
Sir,
Yes, beta, please.
I can't understand from ux equal to u.
You can, what do you understand, beta? Please repeat your question.
Ux equal to u. That first.
Why this ux is u? Because you are launching the particle in horizontal direction. If you are launching the particle here, you can say if projectile is launched horizontally from a tower of height h from a tower of height h. So always remember, whenever this type of problem is there, first you are going to choose here origin. So this is negative direction. So here x coordinate will be 0, it will remain 0, but y coordinate, it is below the origin, so that will be minus h. If this is range, then here x coordinate will be r, it is in positive direction. This is below, so this is minus h. So in this way you are going to consider. So this type of problem you are going to handle with this type of equations. Okay, so today please go through all these equations, whatever I have discussed. Okay, tomorrow I will complete it, as well as I will start the relative motion. Okay, na? I will always discuss the 3 or 4 different cases of relative motion in 1D as well as 2D. Okay, in 1D as well as 2D cases. Okay, beta. Thank you very much.
Thank you, sir.
Thank you, sir.
Welcome, beta. Welcome, beta.
Thank you.
Welcome, beta.